Children of class 10 appearing for board exam 2025 5th. Now this is the first class for class 10, topic optics. This is the foundational course. I welcome all students from class 10 CBSE board that this chapter is very important. Foundation level means in this class SPHERICAL physics you will be introduced numerical base and some important topics on optics. Today my lecture 1 first class. I am considering reflection by plane mirror, deviation by reflection, image by inclined mirrors, terms with spherical mirrors, sign convention and virtual and real image. These are the topics. First case, suppose what is the reflection? You know two basic properties of light. One is reflection, other one is the refraction. Now these are considered geometrical optics because maximum numericals can be solved with a geometry. Now what is the, suppose you consider a mirror. This is the mirror M. Now if a ray of light, this is incident ray, falls on the mirror, incident on the mirror, you take it as a normal, when is a normal, then it is a reflected back to the original media, that is the reflected light. Now children, consider this angle normal, this is the normal, this is incident ray, this angle of incidence, and this is angle of reflection. Now I equal to R, angle of reflection equal to angle of incidence. Now if there is no mirror, ray should pass through OM direction or OL direction, but due to presence of the mirror, ray is deviating along the path OB. Now AO is the incident ray, OB is the reflected ray. Now deviation angle delta समान LOB, that is the deviation angle, that is equal to 180 minus 2I. Again try to understand. You get deviation angle you are getting. This is the incident ray. Okay, this is the normal and this is the reflected ray. Now what is the total? This total angle is 180 degree. Now this ray is deviating in this way. So deviation angle delta, that is equal to LOB equal to 180 total minus I plus I is 2I. So deviation angle equal to 180 minus 2I. Remember it. So during reflection, angle of deviation is total 180 minus 2I. Now there are two types of reflection. Generally we observe, one is the regular reflection. Regular reflection. What is regular reflection? Suppose parallel ray incident on a mirror, after reflection every ray will follow general law of reflection. They are parallelly they are incident and they are reflected in a particular direction, and every ray following the laws of reflection. This is the incident ray and this is the reflected ray. So parallel incident ray, after reflection from the smooth surface, they are reflecting parallelly. As a result, that portion where from the regular reflection takes place, that glitters, that area glitters the surface. So you know in mirror, polished shoe, all are glitters because regular reflection take place. But if the surface is rough, then parallel ray falls just incident, but they are reflecting in different direction following laws of reflection. They are reflecting different direction. They are reflecting different direction following the laws of reflection. As a result, this portion does not glitter. As for example, screen of cinema, where the regular irregular reflection, that is called irregular reflection. That means after reflection, reflected ray scattered at different direction equally. As a result, from every corner screen of the cinema screen, that is white in nature, uniformly illuminated, because from every corner you are getting same reflected amount of light. Now my question is that what I have taught today, first I have shown is a normal incident ray, reflected ray, angle of incidence, angle of reflection, and deviation angle I have calculated. After that I have reflection takes place from smooth surface, then parallel incident ray, after reflection they moves parallel in a particular direction. As a result, that portion where reflection takes place glitters. But in the case of rough surface, I have told you, in parallel ray falls, but this parallel incident ray reflects at different direction following the laws of reflection, but this portion does not glitter. Now after that I shall tell you image formation. Answer number 3. Now two mirrors, plane mirrors, suppose two plane mirrors, one is M1 and other is M2, inclined angle theta. Now if you put an object in between these two, we are getting how many images? You place object O in between these two, how many images you are getting? First, you remember, if number of images 360 by theta, if it is a event, then number of images n equal to 360 by theta minus 1 image, that is image. Now if it is if 360 by theta is even, if it is odd, then same result, 360 by theta minus 1, where object on bisector, object on angle bisector. Clear? Object on angle bisector. Again I am telling, if 360 by theta is even, then image is 360 minus theta minus 1. If 360 by theta is odd, then again it is n 360 by theta minus 1 if object placed on angle bisector. But if object is not placed on angle bisector, then number of images n1 will be 360 by theta. If object not placed on angle bisector. Again I am telling, two mirrors, plane mirrors, inclined angle theta, then any object placed. This object can be placed on the angle bisector, not on the angle bisector, any positions. If 360 by theta is even, the number of images 360 minus theta minus 1, or it is same result if the object on angle bisector. If object not on angle bisector, then it will be 360 by theta. Okay. So what I have taught you, reflection by plane mirror, deviation by reflection, image by inclined mirror, and now I am going to consider image formation by plane mirror characteristics. Now I am just, you remember, in plane mirror what is the characteristics. Before that I should consider what is the characteristics. Now plane mirror, one thing, suppose this is a plane mirror, this is the object. Now clear, this is the plane mirror, this is the incident ray, and this is the reflected. Plane mirror image is virtual. I am going, what is virtual image? Image is virtual image. magnification equal to 1, magnification equal to 1, and object distance equal to image distance. And number 4, there is a vertical lateral inversion, vertical inversion. Then lateral inversion. That is the property plane mirror characteristics. Now, in case of plane mirror, image is virtual, magnification 1, size of the image equal to size of the object, cannot be caught on the screen, virtual image, object distance equal to image distance, and lateral inversion. What is lateral inversion? You know, if you look at the plane mirror, you see your left hand will appear to as a right hand will appear as a left hand. In the case of ambulance, this word is written in reverse order, so that due to lateral reflection, you will get in lateral inversion, you get the image erect. Now, if the image is virtual, you know, virtual image is always the erect. Clear? These are the characteristics. Always remember. So, in the case of plane mirror, size of the image equal to size of the object 1. Next, image is virtual, so erect. Magnification 1 means size of the image equal to size of the object. Image distance equal to object distance. And lateral inversion means left order will be right order laterally. So this is the plane mirror image characteristics. Image characteristics. Children, always remember plane mirror image characteristics. What is the nature of the image? Image is virtual, that means erect. Image magnification 1, that means size of the image equal to size of the object, and image distance equal to object distance, and there is a lateral inversion in the case of plane mirror. Now children, I am going to define virtual image and real image. After that, I should consider two mirrors, not plane mirrors. I should consider two spherical mirrors, very important for your exam purpose. So I am considering what is real image and what is virtual image. What is real image and what is virtual image? Children, what is the real image? Real image. Always remember real image. You always remember real image, always inverted. In the case of spherical mirror, this image formed in front of the mirror, not behind. Again I am telling, it always formed in front of the mirror, same side, same direction as the object is placed. Real image. Definition means, what is the definition I am telling? From any object, ray after reflection or refraction meet at a point and produces the image or forms the image, that is the real image. Real image means reflected ray and refracted ray from the object meeting at a point. It appears to meet, then it is a virtual image. Again I am telling real image. Suppose if from any object reflected ray or refracted ray after reflection or refraction they meet at a point, the second point is called the real image of the first one. If they appears to meet at the second point, then second point is known as virtual image of the first one. Now my question is, virtual image always erect. Virtual image erect. You know, in the case of plane mirror, we are getting virtual image. Gradually we are coming different types of image in the case of spherical mirrors. So virtual image is erect, and you know, I am teaching you virtual image is erect. So this definition may come, example may come. So you consider what is the real image, what is the virtual. Real image, reflected ray, real image, reflected ray, and or refracted ray meet at a point to give you real image. It appears real image. Clear? Reflected ray or refracted ray from any point meet at a point, then they are getting real image, that is inverted in nature. Okay, now I should consider two types of spherical mirrors. Spherical mirrors, this is a transparent perispherical surface. Now this is the center. Now spherical mirror is a portion of the hollow sphere. This is called AB, is called departure, or the diameter exposed to light, that is departure. This is pole. This is center of the hollow sphere, that is also center of the spherical portion. Now if the inner side curved, then it is concave mirror. This is the concave mirror. Outside is silver, that is a concave mirror. And reverse, this is the convex mirror. They will bulging out, that is the convex mirror. Now middle portion of the mirror, that is the middle portion of the mirror P, that is the pole, and that is the center of curvature. Any line passing through pole and center curvature, that is called principal axis. And diameter of the exposed area of light AB is aperture. The spherical mirrors are two types. One is concave and another is convex. Gradually I am coming. Now these mirrors are portion of the hollow sphere. Now center of that hollow sphere is the center of curvature, and middle portion of the mirror known as pole and center curve. Any straight line you passing, that is called principal axis. Very important. Now I am considering focus for the concave mirror. What is the focus? That is the pole. This is the principal axis. Any incident ray parallel to principal axis. After reflection passing through the focus. Pole to focus is focal length. Again I am telling, any ray OA, suppose AB is the incident ray, after reflection, this is the normal, this is I, this is also I. Now question is that any incident ray parallel to the principal axis after reflection passing through a point, that is the focus. Distance from pole to focus is known as focal length. Similarly for convex mirror, parallel ray after reflection they diverge and they appears from a point on the principal axis, that is the focus. Clear? This is the, you remember, this is convex mirror. The convex mirror, they appears to meet at the focus, virtual in nature, and that is concave mirror. Actually they meeting. Now, so in the case of mirrors, we are defining pole, aperture, center of curvature, principal axis, and focus and focal length. This is very important because when you are doing any numericals or any derivation, these terms are very important. One is pole. Number two is focus, focal length. Number four, principal axis. and center of curvature. Center of curvature. Center of curvature. Clear? Center of curvature. So in your today class I have considered two spherical mirrors, concave and convex. I am going to tell you some terms: pole, center of the mirror. This spherical mirror is a part of the hollow sphere. Center of this hollow sphere is the center of curvature. Now center of curvature and pole, any line passing, that is called principal axis. Any incident ray parallel to principal axis, after reflection they meet or appears to meet. In the case of convex mirror, they are called focal point, and pole to focal point distance known as focal length. Now last one that I am going to teach you, that is the sign convention. What is the sign convention? Because during image formation, sign convention is very important. Sign convention, you consider sign convention method. Sign convention. What is sign convention? This is the mirror. This is left hand side. This is right hand side. This is the pole. Object is always taken at the left hand side. This is object. Object is taken at left hand side. Upward is positive. That is positive. Downward is negative. Downward is negative. Any ray along the direction of incident ray, direction of incident ray, direction of incident ray is positive, reverse is negative. Again I am telling, distance measured from pole, distance measured from pole. Clear? Again I am telling, always you take the object at the left hand side, you take the distance from the pole. Any distance measured along the direction of incident ray from the object known as positive, reverse direction is negative, upward is positive, downward is negative. Clear? So today this is the class. From next class we are introducing use of different types of mirrors, how they are used, at the same time how image is formed by the concave and convex mirror. I shall teach my next class. So children from class 10 CBSE board, welcome to my channel SPHERICAL Physics. If you are benefited or if you think this channel is helping you in the long run, please you subscribe my channel and encourage me as a student. I am a teacher. I am expecting my students who are very dearest to me will cooperate and they will subscribe my channel and they will encourage, so that I shall give you next video better, in better way. Thank you.